Today we are going to discuss about the power relations in the AM wave. That means we are going to calculate the power developed by an AM wave when it is passed through a resistance R. Or say we are receiving this AM wave by using a receiver antenna whose resistance is R. Okay, so we are going to calculate what is the power developed by this AM wave on that receiver antenna with a resistance R. We have already studied in our previous class that when we consider an AM signal, it consists of three components: the carrier component, the lower sideband component, and an upper sideband component. So when we calculate the power developed by this AM signal when it is passed through a resistance R, then we need to calculate the power developed by these three components individually, and then we need to calculate that three powers together to get the total power developed by the AM signal. Okay, then how we will calculate the power developed by a sinusoidal signal when it is passed through a resistance R? We know the equation for calculating the power developed is V square by R, where that V is the RMS voltage of that sinusoidal signal. Okay, so when we consider this term, to calculate the power developed by this term, first we need to calculate the RMS voltage of this term. Okay, then we can calculate the power developed by this term as that RMS voltage square divided by R. Okay, that's our general equation. Power is equal to V square by R, voltage square divided by R. And how we will calculate the RMS value? We have already studied the equation for calculating the RMS value for the sinusoidal signal. How we will calculate the RMS value? If V is the peak amplitude of a sinusoidal signal, then its RMS value is that peak amplitude divided by root 2, V divided by root 2. So for this carrier signal, its peak amplitude is Vc, and hence its RMS value will be this Vc divided by root 2. And for this lower sideband component, its peak amplitude is MVc by 2, and hence its RMS value will be MVc by 2 divided by root 2. And for this upper sideband component, its peak amplitude is MVc by 2, and hence its RMS value will be MVc by 2 divided by root 2. Let's now consider that equations. So we can write the total power in the modulated wave as PAM is equal to V carrier square divided by R plus V LSB square divided by R plus V USB square divided by R, where this V carrier, V LSB and V USB are the RMS values of the carrier, lower sideband and upper sideband components respectively. So here we are calculating the total power in the modulated wave by using our general equation V square by R, and that V is our RMS voltage. And when we consider the AM modulated signal, in that AM modulated signal we have three components: the carrier component, lower sideband component and upper sideband component. And this V carrier represents the RMS value of the carrier component, and hence for that carrier component, the power developed by that carrier component is V carrier square by R. And this V LSB represents the RMS value of our lower sideband component, and hence the power developed by that lower sideband component is V LSB square divided by R. Then this V USB represents the RMS value of our upper sideband component, and hence the power developed by that upper sideband component is V USB square divided by R. Okay, and here we are considering this resistance R as our antenna resistance, the resistance of our receiving antenna. Okay, then as I said earlier, the RMS value of the carrier component is Vc by root 2. The RMS value of our lower sideband component is MVc by 2 divided by root 2, and the RMS value of our upper sideband component is MVc by 2 divided by root 2. Now we are going to substitute these values in this equation. Okay, then first consider this term, the power developed by the carrier component across this resistance R, and that is represented by using PC. Okay, that PC is equal to V carrier square divided by R, and we know V carrier is Vc by root 2. Hence Vc by root 2 all square divided by R, and that is equal to Vc square divided by 2R. So the power developed across this resistance R by the carrier component is Pc is equal to Vc square divided by 2R. Let's now calculate the power developed by the upper sideband and lower sideband components across the resistance R. When we consider the power developed by this upper sideband and lower sideband components, that two powers are same, because the peak amplitude for the lower sideband and upper sideband are same, and that is equal to MVC by 2, and hence the RMS values for the lower sideband and upper sideband are same, and that is equal to MVC by 2 divided by root 2, and hence the power developed by the lower sideband and upper sideband across the resistance R will be same. So the PLSB is equal to PUSB, and that is equal to VSB square divided by R. We are representing this VLSB and VUSB as VSB, okay, and both are same, okay, and its value is equal to MVC by 2 divided by root 2. So for this VSB we are substituting this one. So MVC by 2 divided by root 2 all square divided by R, and that is equal to M square Vc square divided by 8R. Then we can rewrite this one as M square divided by 4 into Vc square divided by 2R. So the power developed by the lower sideband and upper sideband across the resistance R is equal to M square divided by 4 into Vc square divided by 2R. Now we are going to substitute these three values in our equation 15. Okay. So the power developed by the carrier across the resistance R is Vc square by 2R, and the power developed by the lower sideband and upper sideband across resistance R is equal to this one. Okay. So by substituting these two values in this equation, we will get that power developed by the AM signal PAM is equal to this Vc square by 2R plus M square by 4 into Vc square by 2R plus M square by 4 into Vc square by 2R. Then in this equation we can see Vc square by 2R is common in all three terms. So we can take this Vc square by 2R outside, and we can write PAM is equal to Vc square by 2R into 1 plus M square by 4 plus M square by 4. Okay. Then we can write this Vc square by 2R as Pc. Okay. So this is equal to Pc into 1 plus M square by 2. Then from this we can write PAM by Pc is equal to 1 plus M square by 2. Let's look that equation. So PAM by Pc is equal to 1 plus M square by 2. Then from this equation we can calculate the maximum power in the AM wave. We know the maximum value of M is 1. So if we substitute M is equal to 1, then we will get the maximum power in the AM wave. So when this M is equal to 1, here it will be 1 square by 2 or 0.5. So we will get this PAM by PC as 1.5. Okay, or we can write PAM is equal to 1.5 into PC when M is equal to 1. So this 1.5 PC is the maximum power in the AM wave.